does observation play any role whatsoever in the scientific method? Is it a part of science? And a lot of people out there say, yeah, of course. How can you explain anything if you have not observed it? Oh my God. That's when I like to get my, my dough roller here, beat them over the head, Okay, so let's find out if this thing called observation, to observer, if any of those have anything to do at all with a scientific method or with science. Okay, we start with this. We start by finding out what science is, because we need to find out, science and scientific method, if they include observation at all, if there's a requirement for observation. And so we look up the scientific method in the Wikipedia, and what do we find? We find the scientific method is what? An empirical method of acquiring knowledge. And I've underlined empirical, or highlighted empirical knowledge, okay? That has characterized the development of science since at least the 17th century. That's when the so-called scientific revolution took place, when they said, hey, we're going to do everything through empirical, we're going to collect knowledge empirically. That's essentially the so-called scientific method of the 17th century. I call it the method of religion, okay, because it has nothing to do with science. That's what I'm going to be arguing here, okay. It involves careful observation. There you have the word observation. Applying rigorous skepticism. What is skepticism? An issue of belief, okay. So this is what they're talking about. They're talking about belief, okay, and about what is observed. Skepticism of what is observed. So one guy observes a snake, and the other guy observes the same snake, and one guy is skeptical. He says, I don't think that's a snake. I think it's a hose. You confused it with a snake. So we have an observation by two different people. They reach two different conclusions, and they think that skepticism, belief of what they thought they saw, is important in this world, in this scientific world. Keep that in mind. Given that cognitive assumptions can distort how one interprets the observation. Yeah, I mean, if it distorts you, and you're on drugs, or you've been, hitting the booze too much, who knows what you observed? And so the question is observation objective? Especially when they're telling you it's not objective. Okay? It involves formulating hypotheses. Okay, what is this? Via induction based on such observations, again, experimental and measurement-based testing of deductions drawn from the hypothesis. Experimental and measurement. You're going to measure, and then you're going to do some experiment. I don't know what for, but that's what they're saying is part of this so-called scientific method. Okay? And refinement or elimination. They're going to be eliminating hypotheses, okay, of the hypothesis based on the experimental findings. Well, elimination means you took a decision. Means it's a belief. You didn't like that hypothesis, you just use this other one, this different assumption, this different theory. So you eliminated. Who gave you the right to eliminate? Well, your mind. You took a decision. It's your belief. Okay, you chose. And okay, they say it's got to do something with experiment, observation, and eliminating hypothesis. Okay, that's in general terms. Let's synthesize all this. Okay, here's the synthesis. So what is the so-called scientific method that came out of the scientific revolution of the 17th century? This, in a nutshell, is it. And I want to focus on the title there. Method of what? Research and persuasion. That's what this is. It's got nothing to do with science. It's got to do with how you do research, how you study something, okay? And persuasion. How do you persuade the peers, people who think like you, to think like you? That's what it's all about. And look at, here you'll see it. Observe, okay? Why do you need to observe? Because you're doing research. Okay, and I'm going to contrast that with something else in a minute. You make a prediction. They say it's a hypothesis. If a prediction is a hypothesis, then the question is whether a hypothesis is the same thing as a prediction, an explanation, an assumption. Are those all synonyms? Okay, keep that in mind, because they're saying it's a prediction. You run an experiment. Why? To confirm, verify the prediction, behavior, or description. Why would you run an experiment? Is it to explain something? No, the explanation has nothing to do with the experiment. The experiment is just to certify or verify for yourself that you got everything under control. But, the experiment itself, you do an experiment in front of people, like Faraday used to do experiments, at the club over there. He used to do experiments, live experiments. So you do a live experiment. What have you learned? I always do an experiment here. The gravity experiment, you let go of the pencil. Okay, so I did an experiment. Is that science? No, I have to explain the mechanism. not the observation or the experiment. I can do a lot of experiments and not understand anything. And so the question is whether experiment has anything to do with science. Measure, you measure for what? What's the point of measuring? I want to explain the mechanism. So I measure the table. It measures 1 meter, or maybe 1 meter and 1 centimeter, or whatever. Is that science? Have I done science so far? You collect data for evidence. What's the purpose of evidence? You're going to be using it to convince someone, to persuade, to recruit them to your way of thinking, to convert them. Is that why you collect evidence? What's the purpose for a prosecutor to collect evidence? It's to convince the jury, to persuade them to think his way, to vote for his theory. That's what it's all about. It's about persuasion. That's all evidence and experiments are for. Experiments are for evidence. Evidence is for what? For persuading. Discover a novel behavior. Okay, so you discovered a novel behavior, something you haven't noticed before. Okay, so you present evidence. Okay, again to persuade and convince. People vote. Okay, this is part of this method. Okay, that's the persuasion part. People vote, and they say, okay, 50% plus 1 voted for your theory, for your hypothesis, which is a tentative theory in some cases. Now it becomes a theory with more evidence, and at some point, I guess it becomes proof. When I guess I don't know what percentage, maybe 50 plus 2%. You know, how do we determine when the flat Earth becomes a fact? More people vote for it. Is that the way it works? Is that what voting is about? By consensus, the peers vote. The result, according to these people, is knowledge. They say, oh, we have knowledge now. Well, what do you mean by that? Well, you repeat the process to confirm the knowledge. Maybe you make an invention, a gadget, which, according to mathematical physics, proves the theory. You know, quantum computers prove that a particle can be at 2 places at once, right? That's what quantum computers mean. Quantum computers prove, right? Because if they work, right, they prove that a photon can convert into a virtual positron, virtual electron, and then recombine again and form a virtual photon. Does quantum computers prove that? Is that what proves the theory? The explanation you just gave? And then obviously you can't avoid the awarding of prizes. You have to certify knowledge. You got to give an award of some kind. So that's the scientific so-called method that these people have. Okay, so what is an observation? Well, let's go to the wiki here. It'll tell us, okay? It says observation is the active acquisition of information from a primary source. Okay? In living beings, observation employs the senses. In science, observation can also involve the perception and recording of data via the use of scientific instruments. Okay, so you either have a conscious being or an unconscious being, the robot. The term may also refer to any data collected during the scientific activity. So data collection is also an observation. Observation can be qualitative, that is, only the absence or presence of a property is noted, or quantitative, if a numerical value is attached to the observed phenomenon by counting or measuring. Okay, so that's what observation is all about. It's collecting data, essentially, or at least one of the key features of observation is that. Okay, let's see why we did this for, or let's see if this works. Here it is. Widen it up here a little bit. The scientific method requires observations. This, I think, comes from the wiki. Of natural phenomena to formulate and test hypotheses. What do you mean test? What are you going to test? So you tested it. And why is that for? To convince yourself, to prove it to yourself, to prove to your peers? Does the person on the other side of the planet, does he accept this? You know, the person who works out there in the farms who's not aware of this, have you convinced him? Does he believe in the same thing? Just because you convinced yourself. You ran this experiment, you convinced yourself, you observed it, you measured, you took data, you convinced yourself of a description. Does that person on the other side of the planet believe the same thing, or does he believe maybe that God did all that and the angels and the spirits interfered with your experiment? Okay? Are you going to convince all 8 billion people on Earth? It consists of the following steps. Okay? Ask a question about a natural phenomenon, make observations of the phenomenon. Okay, formulate a hypothesis that tentatively answers the questions. And if you look at all that, it's all description and explanation. In other words, the question is whether it's a description or an explanation. What is the question we're trying to answer? Are we just going to describe? Is that what the question is? Is that what we're going to answer? We're just going to describe? Or are we going to explain something? Keep that in mind. This is what it's about. If we're going to just do a description, well, that's different than giving an explanation of a mechanism. Okay. First one, predict logical, observable consequences of the hypothesis that have not yet been investigated. Okay, so you do a prediction. Is that an explanation? I mean, if you predict that tomorrow at 2 o'clock, the horse number 5 will win the race, and it does, okay, even if it does, so far all we have is a description. You have no you haven't given an explanation of why that horse won or will win. And if you can tell me why, you're talking about the past. There's something that you know in advance, you could say, okay? It means you have already some kind of understanding that the other person doesn't. That's called explanation. Explanation can only do with the past. Even though it hasn't happened, you've already visualized the movie. You either visualize, watch the movie, have some experience with it. Otherwise, you would not be able to predict. Okay, if the prediction came true, it's because it's just a description so far. But if you can explain it, it's something that comes out of your experience, out of your memory. Okay, you test the hypothesis prediction by an experiment. Again, what is that for? To convince yourself. Draw a conclusion from the data gathered. Well, is the conclusion related to description or to explanation? What do you mean conclusion? Are you talking about a description? Is that what it's all about? Write a descriptive method of observation and the results or conclusions reached. Descriptive? I thought we were going to do an explanation. This is just a description. Okay? Have peers with experience researching the same phenomena evaluate the results. That's voting. That's just everybody raising their hand and say, well, I agree with you. Okay, so they're all from the same religion. They all decided, the peers, from the flat earth all voted for the same theory or description or whatever. Does that make it true? Because, all the Christians voted for Jesus Christ. So again, the question is whether any of these has anything to do with science. And what's the outcome of all this? Well, the outcome of all this, after you do all these steps, okay, this is what we have today. We have all irrational explanations. Here's a listing just off the top of my head, okay. Warp time comes up against the skin of Earth and prevents our planet from flying out of the solar system. They're saying that there's a wall of warp time. They call it space-time, right? And space-time is warped, meaning time is warped. We have a concept that is warped, and that's what prevents the Earth from flying out. You've seen the little marble rolling around a canvas that has a bowling ball, in the center. Okay, so the little bead goes around. Why doesn't the bead fly away? Well, because there's this wall of this canvas up against it, and that's essentially what these people are saying. Okay, that there's a wall of warp time. Matter created itself from the concept energy, Big Bang. 0D, zero volume, infinitely dense mathematical singularity, known as a black hole, moves stars around. Is that what it is? And again, Chandrasekhar proved mathematically, that's what he won his Nobel Prize for, that a black hole is zero-dimensional. Some people are not aware of that. They think that that's not true. Yeah, it is true. Okay? And I've covered that in the past as well. Dark spirit's known as dark energy, right? Counteract cosmic pull of gravity. So here's gravity pushing everything outwards, inwards. You have the Big Bang explosion, right? Everything should come together pulled by gravity, but it's this dark energy that's pushing everything out, from the initial explosion, I guess. A particle can be at two places at once. Is that a rational conclusion? Is that what these people came up with after following this scientific method, so-called scientific method? Okay. The electron is bound to the proton by nothing. Mr. Rutherford, he proved, right, empirically, through an experiment, through observation, that there's nothing between the proton and the electron, and yet the electron doesn't fall to the proton, nor does it fly away spontaneously from the atom. And so please explain why it doesn't fly away or fall to the center, to the nucleus. So we don't have an explanation. These are things that we have today. Electricity, the flow of numbers. What is an electron? It's a bunch of numbers. It's a collapse of the wave function. That's what an electron is. As soon as you go and measure it, the wave function collapses. And what do we have? We have a number. That's what a wave function collapse is. Quantum mechanics does not propose corpuscles. It's called the particle theory, and the particle is, when you look at the word particle, you get down to the nitty-gritty. Particle is a concept. It's a bunch of numbers, or actually one number. And so that's what electricity is, because it's the flow of electrons. Electrons are just numbers, charges. That's what they call them. Light is a wave, and what is a wave? Flowing vectors. We saw that the other day. We have all these vectors, mathematical vectors. They have magnitude and direction. Remember, some are up, some to the side, 90 degrees to each other. They're collectively known as the electric and magnetic field. Okay, that's what it is, a bunch of vectors, and that's what light is, a bunch of vectors that are flowing. Does that make sense? That's what they say it is. They illustrate it. So if you had any doubts, just look at the illustration. You'll see what it is. Okay, mass, a bunch of particles struggling upstream. That's what Mr. What's his name? I forget his name. James. Sorry, skip my mind. The particle, the Higgs flow. It's the Higgs ocean, really, ocean of particles, and particles flow against this ocean that Mr. Higgs proposes out there. Okay, so this is their explanation. They're saying that mass, which is a concept, is the flow of particles against this river, against the current of the river, and some have more resistance than others, and that resistance is known as mass. Does any of that make sense? Because that's their physical interpretations. So these are just a quick listing of irrational conclusions or theories that we have around today based on this so-called scientific method. Okay, so what am I getting to? Well, I'm saying that that here's the scientific method that these people propose. Again, here it is up here. And yeah, then you need observation under that, because the purpose of that is it's a method of research and of persuasion. You're trying to convince the jury. That's why observation is important, because observation serves as a synonym of proof. Here, let me show you my version. Okay, and this is the rational scientific method. We call it science. Okay, we only call it rational science to distinguish it from what the mathematicians are doing, but it's actually science. This is science. What the mathematicians are doing is not even science, it's religion. It's because they don't have rational explanations. There you see, these are the type of explanations that you get, the ones I just mentioned a minute ago. And here you can see why we don't need the word observe or observation. Where do you see the word observation on the right-hand side? Well, you won't see it because it's not there, because you don't need it for anything. What is a hypothesis? It's the assumptions. And what are the assumptions? The object's definitions and the initial scene or the first frames of the movie, of what you're going to be explaining. So you propose assumptions. Remember, this is a way of explaining something to someone. It's not a method of research and persuasion. It's a method of explaining. That's the difference, because we're going to explain rationally how Mother Nature does her stuff out there. And what are you going to explain? You're going to explain mechanism and causes. That's under, physics. Philosophy, you explain something else. Okay, we call it reasons and purposes. Okay, and here's the conclusions to this, so that you can see why we don't need observation at all in science. Okay, and again, people ask. Let me put this question this person asked the other day, because this is the question on everybody's mind. That's the one we're going to be answering here. Okay, they say, without observation, what is there to explain? Well, imagine that you go to the conference and you're going to be explaining a mechanism. Why in the world do you have to say, I observed? Let me tell you what I observed. Now, you don't have to say, let me tell you, I observed gravity. I observed how the pencil fell to the floor, fell down. Do you need to say that? It's an irrelevant issue, totally irrelevant whether you observed it or not. You came to the conference to explain a mechanism, and you have to make an assumption. What are you going to make the assumption about? About the invisible stuff, about the invisible objects. That's what they're called. They're called objects that Mother Nature uses. The invisible, intangible objects that produce the phenomenon we call gravity. That's what you're going to explain. Are you going to say that you observed gravity? Are you going to say, irrelevant, that you observed how the pen fell, at what speed or what acceleration? What does that have anything to do with anything? It's irrelevant, totally irrelevant whether you observed it or not. It plays no part whatsoever in science. In explanatory science. It has in research science, if you call that science. You can say, yeah, I observed, these are the steps that you got to take in order to do research. Fine, that's one thing. It's got nothing to do with science. Science is explaining, not how you came about your explanation. You're going to go out there and tell the crowd and explain an objective, you're going to give them an objective explanation of how Mother Nature does her invisible tricks. The visible stuff we've already answered. You don't need to say, I observed the pulley, the rope pulling box around, tied around, wound around the pulley. You don't need to say any of that. You just say, look, there's this box that goes up. And how did it go up? Well, I pulled on the rope that was wound around the pulley. We're done. You don't have to say observe for anything there. Even if you did observe, it's irrelevant. You got to focus on the explanation, not give your testimony of saying I observed. What sense does it make in an explanation to say that you observed? Okay, especially things such as, or phenomena such as gravity or magnetism. Are you going to say, yeah, I observed that this magnet attracts that one? Okay, so you observe. Who cares? Who cares? Tell me the mechanism of how this magnet attracts that one. For that, you have to make an assumption about what's in between these two magnets. Observation plays no role in it because I cannot observe what's between these two magnets. And so to say that you're going to explain the observation that one magnet attracts another, okay, it's idiocy. That's what it is, using the word observation or observe or observer in any of those contexts. You don't need it at all. It's irrelevant, okay? And so here's, again, my conclusion on that, so that people see where I'm coming from on this. You have to distinguish the method of research and persuasion that these people use versus the method of explaining rationally. We're saying science has nothing to do with the method of research. Science is about explaining. That's where you have to burn some calories. But to say, this is how I studied. Well, it doesn't mean that because you studied, you learned anything. It doesn't mean you're going to pass the test because you studied. Because you say, well, this is how I spent my weekend. I observed the book. I opened it up. I read everything. Yeah, and then you failed the test. That means you didn't learn anything. So who cares if you observed? Who cares if you read? Who cares if you did research if you didn't learn anything? No, the juicy part of science is coming up with an explanation, especially for how Mother Nature and Father Universe, run the world. Method of research conduces to these irrational explanations. That means the method of research that all these people are following does not produce rational explanations. We have not one rational explanation from mathematical physics today. They're all descriptions. The descriptions are mathematical descriptions. Is a mathematical description science? That's what you got to ask. Studying doesn't mean understanding, again. Okay, and method of persuasion is known as religion. So if that's what you did, you collected evidence, you did an experiment, collected evidence, and brought it to the conference, does that mean that you did science? No, if you're just going to use the evidence to persuade the jury, all you're doing is religion. That's got nothing to do with science. You're just trying to change opinions. It's irrelevant and subjective to begin an explanation of a mechanism by saying that you observed something. You're testifying. That's all you're doing. You're introducing witnesses. Okay? And you need not have observed. You need not, again, Stephen Hawking, did he observe a black hole ever in his life? Does that mean he cannot hypothesize and say, let us assume there's a star that collapses to a point, it's got infinite mass, and that's what's compelling other stars to move around it in circles, orbit. You can do it without having observed anything out there. You could be blind for all you care, and someone brings the issue to you and say, well, yeah, I can tell you how that's done. It's done through mass or whatever your theory is. So you did not need to observe it yourself. You should not begin your explanation by saying, I observed, because all you're doing is testifying. You're trying to show that if you observed in the lab, who's going to challenge you? If you saw it with your own eyes and all these other people who were with you, we saw the photon go by. Oh, yeah. And you saw the photon turn into two virtual particles, which recombined and turned into a virtual photon. You saw all that. You saw entanglement. You saw how this particle here sent magical spirits and affected that particle over there. You observed that, right? Or did you just observe two particles? Okay. And again, observe means watch. You can only observe something over time. This is not see or look. Look means that you just gawked. See means that you gawked and understood. But you can see a wall and you can see, a painting. You can see a still image. Observe is something else. Observe is not see, not a synonym of see. Observe is a synonym of watch. It involves time, it involves motion, it involves many frames of the film. Okay, so, and then a lot of people think that explanations have something to do with technology. And they say, well, if you cannot produce a gadget, some technology, then what is your theory worth? The theory has nothing at all to do with technology. One of the things that a fellow like Nikola Tesla, he never understood. He thought he was a scientist. He was a guy who did inventions. He had no idea what science was. He explained everything with spirits. Okay, he used words such as energy, field, mass, less mass because he was not on the mass side, but he used words like field and energy and charge, concepts. That's what he moved around. And towards the end of his life, he put the icing on the cake. He said, someday, we'll discover what electricity is. Meaning that towards the end of his life, he had no clue what electricity is, and there is no one on planet Earth in mathematical physics who has any idea what electricity is. They cannot explain it. They cannot explain the mechanism. They say it's a flow of electron beads, but for that you have to have the right atom. You cannot, if you cannot illustrate your atom to begin with, you have no theory. You cannot even begin to theorize.